Oh, my light's not on. Ah, it's so bright. There we go. Check and make sure my camera's actually pointed at the right thing. Oh, look, it's me. It's always a fear of mine when I live stream is that I don't pay attention to this piece here, which is what you actually see. I just start going, and then I don't watch the videos afterwards, so I have no idea what's actually going on. Quality. Anyways, we've already designed a lot of stuff. It's time for us to turn this into a 3D printable component now. So I'm going to just step you through the process of taking your existing design we've already come up with to this point and turning it into something that we can start working on 3D printing. So here, you're going to want to do this piece by piece. Obviously, at this point, I have developed almost all of the pieces that are going to be in this. Still have some modifications, still have some fun things to play through, but overall, I'm mostly done with all of my designs. So what I'm going to do here is I'm going to pop open my, well, no, before I do anything, I'm going to take this entire folder, copy it, paste it. All of my SolidWorks components are in here, so that when I copy and paste it, what I'm going to do is I'm going to call this VC 3D print. Okay, and this is going to be a completely separate folder. So once again, copy and paste all of your files. Do not modify the existing files. Copy and paste them. Put them into a brand new folder. Okay. So now that they're all in a brand new folder, I'm going to go in here to the full assembly, and I'm going to pull out the big pieces. Now the idea with a 3D print is that you are going to actually end up scaling down pretty much everything. So any piece that cannot be scaled down or that would not nicely be scaled down, thank you. It's rebuilding it to identify the now new files that are located right next to it, which have the exact same file names. You don't want to change your file names. It's just making sure that everything is present. So what we're going to be looking at here is I want to 3D print the big pieces. Okay, I don't just want to 3D print everything. I think that would be a bad piece to go through. But I do want to 3D print like this dust reservoir, the body, the battery. The handle might be a little small. And then this piece here that sticks out of the body that is called the intake, and that's mounted to the fan mount. I'm also probably going to want to 3D print that motor mount separate. So I'll have 5 different pieces that I plan on 3D printing. I can also 3D print this hose. So that'll be 6 pieces. Dust reservoir, body, battery, fan mount, and the motor mount. And the hose. Okay, so now that I've looked at this, I can now close this because, as I've said, I've already identified which pieces I want. I now no longer need this open. And I am about to absolutely butcher some of these parts. So let's go to open. Here I'm going to make sure that I'm in the right folder. Here I'm in the 3D print folder. I'm going to open up the body. So this will be one of the pieces that I create. And the goal of editing these pieces is I need to take out any geometry that is smaller than what would be about 1/8 of an inch when it's scaled down. So here, let's just do some basic measurements on this to establish what kind of a scale we're going to be needing. So here I will go into, I don't know why I clicked that, measure, and I will measure just overall, what is it, the size from this edge to this edge. Distance is 11 inches, so it's 11 inches wide. I'll try to select this edge. May not be able to select this edge. See if I can just pick this face, this face. Nope, I can't. So I'll try again. Can I pick this face, this face? Center to center distance is 10.25 inches. Which this has a 0.75 inch radius, so it'd be 11 inches from the center here to there. So 11 inches. And then 11 inches, and then this radius here is 4.38, so it'd be about 15.38 inches by 11 inches. So 15.38 by 11. Now I want to scale that down so that it's 3D printable. Okay, so if I scale that down, what I end up with is it has to fit inside of a 10 inch by 10 inch square that the 3D printer can actually handle. So I can try to print exactly one piece that is as large as possible, or I could just try to print all of them to some kind of scale. Here, if I print this to a 1 to 10 scale, that'll be about an inch, which for me, that would be enough to be able to showcase, you know, this is a vacuum. And then I can show the motor mount, and I can show relative sizes and all of that jazz. So that's actually what I'm going to do, is I'm going to print at a 1 to 10 scale. Now, what does that mean? It means that anything that's smaller than 1.25 inches won't really show up. Actually, it's closer to about 0.6 inches, but whatever. Because the 3D printer it prints approximately like 1 millimeter or something every round, or sometimes it's 1/10 of a millimeter, which means that anything smaller than about 1/10 of a millimeter can't be handled. But I just tend to round that up to about 0.03 to 0.06 inches. So anything that's smaller than a 1/16 of an inch would be translated then to about 5/8 of an inch when you multiply it by 10. So here I'm planning on a 1 to 10 scale, and I'm going to design everything so it has at least 5/8 of an inch everywhere. So anything that does not have 5/8 of an inch, I'm going to delete. Now, first of all, this vacuum body, when it's fully enclosed, it's not going to show anything anyways. And at a 1 to 10 scale, I don't really have like, look at my tiny pieces, they fit inside of my body. I don't really want that. So I'm just going to close this whole thing off and have a slot for the battery to fit in. And that'll be it. So here I'm going to keep my cut extrude, but I'm going to delete my shell. Okay, and that does change a lot. Okay, now I need to make sure that I should make sure that that size is deep enough for my battery, but I will check and make sure that it's deep enough for my battery. So here it goes in 4 inches, so that'll be about 0.4 inches when it's scaled down by 10. I might make that just slightly larger, maybe go into 5 inches. And there we go. Then my battery will sit in there a little nicely. These holes here are way too small to be 3D printed, so I'm just going to remove them. You go away. Yes. You also go away. And then I'll exit sketch. So now I just have the hole for the battery to go in and the body. This piece is now ready to 3D print. These curves on here are 3/4 of an inch with a radius, which would be about 0.075 inches radius around, but that's still 3D printable. So this one's good. Okay, so that's one of my 6 pieces down. Second one is if I go into my my reservoir assembly. Now, the issue with my reservoir assembly is that it's multiple pieces. Yes, okay, I can try to modify all of the pieces to make them nice and simple, but what I'm going to instead do is take this. I'm going to beef these things up so that they're thick enough that they would actually 3D print. And then I'm going to take out that center piece. Do note that when you 3D print this isn't accurate because we're not printing to scale and because this is just a model. It's a physical model. That we're not trying to make this super accurate. I'm going to delete this piece. I'm going to delete extruded thin for that one. Gross. I'm gonna make that solid piece. This one extruded thin. I'm gonna turn off the thin feature. And hit OK. And that should just make it a solid circle. Which is what I want. And that actually isn't a solid circle. So what I can do is I can... Yeah, it doesn't like switching from thin feature to not thin feature. Which is unfortunate. Trying to force it to do it now. I don't think it will. It's going to continue to assume it's a thin feature. So I'll just have to replace this. I'll delete this. It'll say, what the heck are you doing? And then I'll take this sketch and do an extruded boss base from this circle up to surface. And then I'll pick this surface. Merge results, hit yes. And there we go. Now we have this piece. Although it appears that it went all the way through because I did a cut earlier. So just delete this. Yep, and there we go. Now it goes into this. I'm going to make this entire thing solid. Oof. It does not want me to make it the whole thing solid. So what I can do instead is just go in and then basically just I'll sketch on this surface. I'll draw a circle. I'll go from here to here, which is fully dimensioned, and then take that and I extrude it, and instead of giving it a dimension, I'm going to go the other way and then up to surface and then extrude up to this top face up here and hit OK. And now that's one solid body, which is how I would want it to print. Okay, this is solid here, this is solid here. So now the only things that are too tiny to print are going to be these things right there. So I'm just going to beef them up. It's going to be way thicker than they actually look, but it'll be 3D printable. So I got these pieces here. We go in, add the sketch. And remember, according to what I just said, with doing a 1:10 ratio, I have to get everything to be at least 0.625 inches, which is about 5/8 of an inch. Anything smaller than that is not going to be 0.06 inches when it gets printed. So I'll have to remove it. So your 0.13, that's actually not big enough. I'm going to make this 0.75. Heck, why not? Makes everything huge. And that right there showed 3D print. So now I exit sketch. And there we go. Now my dust reservoir showed 3D print, and that would be a good model of my dust reservoir. So I'll go ahead and save this and move on to the next piece. So that's 2 out of 6 down. The next piece that I wanted was battery. Now, I can honestly tell you right now, I made this battery a rectangle. This, as it stands, could be 3D printed. Because at a 1:10 scale, it's still a rectangle. So we're done there. That's 3 out of 6 pieces. That was fast. So here I am going to go into my my fan assembly and just take a look at some of the pieces. Now when this comes in, I want to eliminate all of my tiny geometries. So here I'm just gonna chop that piece off. I would probably just fill in this entire circle and make this thing one solid part. That would be me. So that's what I'm gonna do. I'm just gonna make it a solid, everything solid. Now this is an assembly. This is not a single part, it is an assembly. However, you can export this as an IGES file, or step file, I should say. If I want to save as, I can save it as a new document name. I can save it as a step file. Where are you, step file? Yeah, and that would be acceptable on most. Oh, I guess STL. My bad. I could save it as an STL file, and that is a 3D printable file. So even though it is an assembly, I can save it as an STL and print it. Now MakerBot actually has the ability to print SolidWorks parts and assemblies, which is nice. However, I've just typically found that when it comes to an assembly, it's easier to save assemblies as an STL file rather than trying to force this to to be an assembly in MakerBot. So here, in order to fix this, we're going to have to fill in this component, then this component here. Otherwise, I'll leave everything else as is. So I'm going to open up the motor mount, the fan mount, I should say. And I'm just going to make it solid. So here, this hole that I cut out, well, certainly these holes that I cut out, those are gone. Apparently I made some kind of a cut down here. Oh yeah, that's gone. Yeah, I made this cut there. That's gone. Alright, and now I just basically need to fill in this entire piece. So what I'm going to do is I'm going to go back here. This cut extrude I'm going to delete, which is going to eliminate a few things. I'll hit yes and see if, oh, yep, Control Z. That's weird. Why would a plane be dependent on a cut? That's weird. I feel like I drew that on the plane. Let me see if I can't move this up. Then hopefully I can just delete this. Why is boss extrude 2 dependent on the cut? Oh, I guess that kind of makes sense. I need to go fix boss extrude 2 so that it is no longer dependent on that cut. So to do that, I'm going to delete the lines. Turn this into a solid box. And then exit sketch. Gonna ignore the errors that come up. And I'm basically gonna go back down here and delete everything that had an error. And there we go. Now we don't have any errors. Now it's just a solid piece. Now I'm going to fill in the inside of it too. So let me pull out a sketch. This was just a circle. Nice. So I will just edit this feature. Oh, never mind. I shelled this thing. That's right. Well, I don't want to shell it anymore. And there we go. Huzzah. So there we go. Now that piece is done. I will need to go into the other pieces of my fan assembly and make sure they're solid. Here, this is going to update. Yes, I want to rebuild. I got to fix the intake, but outside of the intake, whatever. I'm going to not care about the breaks that occur on the assembly side. I'm just basically trying to fit the geometry. So we'll go into the intake, fix that real quick. And then I'll leave everything else as it is. If it doesn't print that gear on the bottom, I'm not going to be terribly upset. So intake. I'll just make the whole thing solid. All right. So first off, delete the shell. Second off, I'm going to delete anything that's a cut. So here, I know that that's actually going to cause problems in the assembly, and I still don't care. All right, let's see, what is this piece here? Boss Extrude. I'm going to go into the sketch. I'm going to make this go all the way to the top, and I'm going to remove that circle. Again, because the circle is smaller than 5/8 of an inch. So if I just get rid of this, yes, it's going to break a few things on the assembly. No, I don't care. And exit sketch. Now, when I extrude this piece here, instead of doing a blind extrusion, which is what I had, I'm going to have it extrude up to the surface. I'm going to have it extrude up to here and hit OK. That'll just print nicely. There we go. It's kind of a much grosser looking one. Here, this piece, well, I don't want that hole cut in the middle there, so what I'll do is I'm going to go into my sketch and I'm going to remove that hole. In fact, I'm going to remove both of these holes. Yes, it's going to break some pieces on this drawing. No, I actually don't care still. As long as I don't move any of the other lines, everything still has the same dimensions. So even though I'm poorly constraining this, it is an acceptable way of making a 3D print. Now, by hitting ignore error, what it's telling me is that this piece here did not have the correct geometries because they were constrained to some lines that are currently now gone. So I'm working on this sketch right now. Well, I don't really want this line to exist. Nor do I want this line to exist. Nor do I want that line to exist. Instead, I want to take this point and this point and merge them. Of course you wouldn't. So, you know what, I'll just create a circle here. We'll do 3-point circle. This point, this point, this point. Hit escape. Then I'll trim this outside circle. And there we go. Now I have a shape to extrude. So if I hit exit sketch, it's still going to tell me that there are problems. Yes, I know, but at least that thing is full. And that's what I wanted. So I'll just go ahead and save this. And now my fan mount, I can go back into the assembly. It'll ask me to rebuild. It'll tell me there's a bunch of errors. I'll hit close because I know I created a bunch of errors. I deleted these holes that were used to mount it. But I'm just going to go ahead and file, save this as continue to ignore. Instead of as an assembly file, I'm going to save it as an STL file and hit save. Gives me the basic geometries of the STL file, and I hit yes. And there we go. So that's 4 out of 6. Let's go ahead and open up the motor mount. I might want to close some of my other SolidWorks files at this point. Oh, it saved everything together. Oh, boy, that's sad. I don't want though. I don't want all of those. Let me see if I can't save this as an IGES file. It should save all as one IGES file. Should, anyways. So if I hit save, looks like I tried to create an IGES file for each one of those. Nope, there's one. So then this could be turned into an STL file. But it's basically one part, and that's what I want. So I would say this is an IGES file. Alright, now it's time to close some of these. I don't even want to try to open up full assembly and see what that mess looks like at this point. Don't save, close. All right, so we'll open up the motor mount. I guess the motor assembly. And we'll simplify this part by basically making the motor mount solid. And when we make the motor mount solid, and then I'll probably just make that gear go all the way down there. So I'll make that gear like an inch longer. All right, and then once I've done that, then I just have to fix the hose, and then I'm ready to 3D print all of this. So all I've done is I've gone through and I've made everything thick, which is great. So I'll open up the motor. Oh, I'll open up the motor gear. And then I'll make it an inch longer. Just to make it bigger. Nah, 1 inch total, actually, would be all it would need. File save. Now open motor itself. I'm going to remove these holes, but other than that, I should be fine. That axle is about 5/8 of an inch, but it's going to have a gear on top of it anyways, so it should actually print. But click these two, delete them all, goodbye, and then save. And then I will open. And I need to fix the motor mount. And here, I'm just going to make the whole thing solid. So I'll delete this cut, extrude, hit yes. I'll delete the boss extrude, hit yes. And then I'll just basically take this sketch here, which I extruded, here it goes from this plane downward. I'll just set direction 2 and have it extrude all the way up to the top up here. There we go, solid piece. File save. So now when I go back into my motor assembly, yeah, rebuild it. Look at how thick that thing is. Yes, I know I deleted some of those constraints. There we go. That's my motor assembly. I will go ahead and save as. I'll save this as an IGES file. And that's 5 of the 6. Now, last one is the hose. Hose is pretty easy because, well, there was only like 2 things I did to make the hose. And I think there's only one actual, yeah, it's just a sweep. So I go in here, fix sketch 1, because my outer diameter is 1.25 inches or so. If I just delete this circle, and then I hit exit sketch, we're good. Hit save. Now all of those pieces are ready to be 3D printed. So I can plug them into a 3D printer, and that's all. So that's how to make some quick modifications to take a non-3D printable piece, remove all the tiny pieces from it, and then make it 3D printable. Okay, now any features. I could try to print small features onto these if I really wanted to, if I felt they were important. Small features on a 3D print actually do make your 3D print look better. I just don't want any on mine. So, alright, in the next video, we're going to be making some modifications to the body to accommodate for, basically I want to make it look nice. I didn't do that in the body last time. I was just trying to rush so that I could get to a 3D printed, well, talking about 3D printing. But I will fix that in the next video, and then from there, we'll start making drawings.